So for today, we're going to talk about the Laplace transform of sine and cosine function. And for today's video, I'm going to show you how to derive the Laplace transform of sine and cosine function using our formula for finding the Laplace transform of any function in terms of time. So again, this is our formula. F of s is equal to the integral of f of t multiplied by e raised to negative st dt evaluated from 0 to infinity. So let's get started. How about we get the Laplace transform of cosine at, where a is any constant, okay, any constant value, okay? So we are going to apply it in our formula again, wherein our f of t becomes cosine of at, okay, multiplied by e raised to negative st dt. So as we can see here, a is any constant and we are integrating with respect to t. So in order for us to find the integral of this, we have to use integration by parts, wherein we can choose u, and we must choose u as cosine of 80. And our du, the derivative of cosine, is negative sine, okay? Negative sine of 80, but the derivative of the inside function with respect to time would be a, so this would be multiplied by a. So negative a sine 80. And we have the dv, of course, e raised to negative st dt. To get the integral of this, that is v is equals to negative 1 over s e raised to negative st. How did we get that? Okay, again, if we let u is equals to negative st, we differentiate this with respect to t. We have negative s dt, and if we are concerned on getting dt, we have dt is equals to du over negative s, such that if we're going to substitute it here, so we have e raised to u multiplied by dt, which is du over negative s. That's why we have negative 1 over s outside of the integral. So negative 1 over s integral of e raised to u du. So if we integrate e raised to u, that is e raised to negative st. Okay? So that's the history behind that. Okay. So we know that from our integration by parts, the formula for integration by parts is uv minus the integral of v du. Okay? So that is what we are going to do here, wherein we have the u, which is cosine of 80 multiplied by negative 1 over s e raised to negative st, okay, minus, that is that minus sign, integral from 0 to infinity. Oops, that's it, from infinity, not to a, okay? And of course, this is our uv. This should be evaluated from 0 to infinity. Okay, let me just rewrite it clearly so for you to understand. So this should be evaluated from 0 to infinity minus the integral from 0 to infinity of the v du, v multiplied by du. So we have the v negative 1 over s e raised to negative st multiplied by du, the negative a sine of 80 dt. So it must have a dt here because we differentiate this u with respect to t. Okay? So let's first try to evaluate the limits of this. So we are going to substitute the values of the upper limit minus the lower limit to the value of t. Okay? Substitute to t. So because we integrated with respect to t. So we have cosine of a times infinity, that would be infinity, multiplied by negative 1 over s e raised to negative s multiplied by infinity, okay, minus the lower limit, okay, so minus, that is minus the cosine of a times 0, that is cosine of 0, multiplied by negative 1 over s e raised to negative s times 0, okay, that is the lower limit, okay, that is this term, whole term is simply we evaluated the limit of this, okay. So on the other term of our equation, we have negative a. We can notice that we have a constant negative a, constant negative 1 over s, because we are only integrating with respect to dt. So we can factor out this negative a, negative 1 over s, outside of the integral sign. So negative a multiplied by negative 1 over s, that is positive 1 over positive a over s multiplied by the negative u. So we have negative a over s. Did you get? So we have negative a multiplied by negative 1 over s, that's a over s, and we have a negative or the subtraction sign here, okay, minus sign here, so it becomes negative. So integral from 0 to infinity of e raised to negative st multiplied by sine of at dt. Okay, if we evaluate this, this term is e raised to negative s multiplied by infinity. This is 0. So 0 multiplied by this should be 0. Okay, minus negative 1 over s multiplied by e raised to negative s multiplied by 0. So this term would be, e raised to 0 would be equal to 1. So that would be negative 1 over s times 1 is negative 1 over s. And cosine of 0 is also 1. Okay? So that we have negative 1 over s times 1 is negative 1 over s. Distributing, or we have negative 1 over s here. If we distribute the negative sign, this would become positive. Okay? So we have plus 1 over s here. Minus a over s integral from 0 to infinity of e raised to negative st multiplied by sine of at dt. Okay? So, let me just rewrite this. And as you can see here, we have again an integral that requires integration by parts. So we have to let u again is equal to sine of at. Sine of at, derivative of u with respect to t is a cosine of at dt. And again, our dv would be e raised to negative st dt, which is this, okay? And we have v, again, that's pretty similar to our v a while ago, okay? The same dv and the same v, negative 1 over s e raised to negative st. So again, using the formula uv minus v du, so we have 1 over s minus a over s multiplied by the integral of this, which is uv minus the integral of v du. So we have uv. If you multiply this, we have u times v. We have negative 1 over s e raised to negative st multiplied by v. Okay, multiplied by u, which is sine of at evaluated from 0 to infinity minus the integral from 0 to infinity of the v du. V multiplied by du, negative 1 over s e raised to negative st, that is our v, multiplied by du, we have a cosine of at, okay, this is multiplied, dt, okay? So, and again, simplify our work, okay? We can, what? We have 1 over s minus a over s. We can distribute the limits so that we have negative 1 over s e raised to negative s times infinity. Sine of a times infinity would be infinity minus the negative 1 over s e raised to negative s times 0, lower limit, multiplied by sine a times 0 would be sine 0. So notice how these two terms, upon evaluating this term, notice that negative 1 over s multiplied by e raised to negative s multiplied by infinity, that this would become 0. Okay? 0 multiplied by this would be 0. Okay? And as you can see here, we have sine of 0, which is 0. So any number multiplied by this would be 0. So notice how this term is only equal to 0. Okay? So this should be equal only to 0. So what will happen here is that, okay, that is our definite integral. This is that. So we have in this side, okay, we can factor out a again and negative 1 over s because we are integrating with respect to t only. So we have a times negative 1 over s, negative a over s, and we have negative sign here or subtraction sign here. So we have negative a over s multiplied by negative, that becomes positive a over s, the integral from 0 to infinity of e raised to negative st cosine of at dt. And if I'm going to rewrite this, so as to make this clear, so this is multiplied, this whole equation of ub minus integral v du is multiplied by a over s here, okay? Just like in our equation here. So we have 1 over s minus a over s, okay? So this is 0 minus 0. So plus or a over s integral of 0 to infinity of negative e raised to negative st cosine of at dt. I can distribute this a over s, multiply inside. So we have 1 over s minus a squared over s squared. The integral from 0 to infinity of e raised to negative st cosine of at dt. So as you can notice here that we go back, okay? We go back to the original integral that we are trying to integrate. Integral from 0 to infinity of e raised to negative st cosine at dt. And if we are going to look at that, this is our first function, okay? So, what is this left side of our equation equal to? Okay, this is also equal to the very first integral that we are trying to get, which is e raised to negative st cosine of at, okay, because that is the equal here, or the term here. We are trying to integrate this from the very start, and it happened that it appears again on the right side of the equation. So we have this one is equal to 1 over s minus a squared over s squared integral from 0 to infinity of e raised to negative st cosine of at dt. So what are we going to do in order for us to eliminate this? If we transpose this term onto the left side, so we have 0 to infinity of e raised to negative st cosine of at plus, this becomes a plus, a squared over s squared, okay, a squared over s squared multiplied by the integral from 0 to infinity of e raised to negative st cosine of at dt is now equal to 1 over s. Okay, so as you can see here, we can factor out this term because it's common on the two terms. So we have integral from 0 to infinity of e raised to negative st cosine of at, okay, multiplied by, I can factor out this would be 1 plus a squared over s squared is equal to 1 over s. Okay, so we can isolate this again, okay? So, but first we have to simplify this. From 0 to infinity e raised to negative st cosine of at, okay? If I'm going to simplify this, this will be s squared plus a squared over s squared is equal to 1 over s. And if I'm going to multiply the whole side of the equation by the reciprocal of this, okay, so as to eliminate this on the left side of our equation, s squared over s squared plus a squared, multiplying that to our equation, so we are left again with this on the left side, which is e raised to negative st cosine of at evaluated from, okay, we have dt here, we forgot the dt here, okay, so we forgot the dt, so we have on the left side of the equation still this, and on the right side would be, okay, s squared over, okay, s squared plus a squared times 1 over s. So as you can see, the s here would cancel, okay, so that the Laplace transform of cosine of at, okay, is simply equal to s over s squared plus a squared. Okay, so what does this tell us? If we're going to get the Laplace transform of cosine of at, where a is any constant number, so we have s over s squared plus a squared. So for example, we want to get the Laplace transform of, what is the Laplace transform of cosine 2t? Okay? Cosine 2t. So our a here is 2. So in order for us to find that, we have s over s squared plus a squared, which is 2. Okay, 2 squared. So we have the Laplace transform s over s squared plus 4. That's how easy it is if we have the Laplace table. But I've shown you the derivation on how they arrive at this formula. Another example, take the Laplace transform of sine of, or cosine, cosine of 3t. Okay? So that would be s over s squared plus 3 squared, 3 squared, which is a squared. So we have 9 here. Okay? So that's how we find the Laplace transform for cosine. Okay? For cosine. So how about for sine? Okay? Let's try to derive the Laplace transform of sine of 80. Okay? So the same formula, we have f of s, okay, which is from 0 to infinity integral of e raised to negative st f of t, okay, dt. So our f of t would be sine 80. So we have what? From 0 to infinity, we have sine of 80 multiplied by e raised to negative st dt. And again, if we apply integration by parts, we have to let u as sine 80, derivative of u with respect to t, that would be a cosine of 80 dt. And we have a dv here, which is e raised to negative st dt, of which that is very similar to our example a while ago. So that would be the v. Okay, again. So, applying the formula, we have uv, negative 1 over s, e raised to negative st, our v, multiplied by u, which is sine of 80, evaluated from 0 to infinity, because that is still our limit, okay, minus the integral from 0 to infinity of the v du, negative 1 over s, e raised to negative st, and we have the du here, which is a cosine of 80, okay, dt. So again, let's first evaluate the limits of this. So we have negative 1 over s, e raised to negative s, multiplied by infinity, sine of a t infinity times constant, we have the infinity, minus negative 1 over s, e raised to negative s times 0, the lower limit, sine of a times 0 is sine of 0. Okay? And on this term, I can factor out again a because we are integrating with respect to t. And I can factor out negative 1 over s because we are integrating with respect to t. So we have a times negative 1 over s, that is negative a over s. And we have a negative sign here, so this becomes positive a over s. The integral from 0 to infinity of e raised to negative st multiplied by cosine of 80 dt here. Okay, so let's evaluate this. Again, this would become 0 because of this term. And this is 0, again, because of sine of 0. So this is simply, the whole term is 0. So we have now a over s, the integral from 0 to infinity of e raised to negative st cosine of 80 dt. And again, in order for us to integrate this, okay, we need again to let u, okay, to use IBP, let u as equal to cosine of 80, and du would be negative a sine of 80, we have dt, that is simply derivative. So again, our dv is still the same, and our v is still the same, okay? So apply again the uv minus integral of v du. So take note that the integral of this is multiplied by a over s. So a over s multiplied by the integral uv minus the integral of v du. So we have u times v, which is negative 1 over s e raised to negative st cosine of 80 evaluated from 0 to infinity minus the integral from 0 to infinity of v du, v, okay, du is this negative a sine of 80, and we have dt here. Okay? That is multiplied by a over s. And again, if we're going to analyze this once and again, okay, let's try to analyze this again. So if we have substitute the upper limit, what will happen? Okay, a over s, negative 1 over s, e raised to negative s times infinity, cosine of infinity here. So obviously, because of this term, this would become 0, minus, okay, minus of the negative of 1 over s, because that's the lower integral, okay, lower limit, I mean, e raised to negative s times 0, multiplied by cosine, okay, a times 0, okay, is still 0 because we have to substitute the value of the lower limit to t. So that becomes 0. A is constant multiplied by 0 is cosine of 0. Okay? And by this, okay, in this side, we can again factor out negative a, negative 1 over s, that's a over s. We have a minus sign here that would become a over s. Okay, we can factor out that. Okay, again, so integral from 0 to infinity of e raised to negative st sine of at dt, and all they are all multiplied by a over s. So what will happen here is that e raised to negative s times 0 is e raised to 0, which is technically equal to 1, and cosine of 0 is technically equal to 1. So we have a over s multiplied by, okay, negative 1 over s times 1 is negative 1 over s, and we have a minus sign here. If we distribute that, that would become 1 over s minus a over s, this one, integral from 0 to infinity of e raised to negative st sine of at dt here. Now, if we distribute this, we have a over s squared minus a squared over s squared, and we have the integral from 0 to infinity e raised to negative st sine of at dt. And again, we go back to our first uh, uh, this is what we are trying to find, and our integral goes back to the same integral. So the left side of the equation is also this, because we are trying to find the integral of this. So we can rewrite this as completely as 0 to infinity of e raised to negative st sine of at dt is equal now to a over s squared minus a squared over s squared. Okay, integral from 0 to infinity of e raised to negative st sine of at dt. And if I'm going to transpose this term on the left side, we have from 0 to infinity of e raised to negative st sine of at dt plus a squared over s squared, integral from 0 to infinity of e raised to negative st sine of at dt is now equal to a over s squared. And I can factor out this integral because it's common both on the terms. So we have from 0 to infinity e raised to negative st sine of at dt multiplied by, this would become 1 plus a squared over s squared is equal to a over s squared. Okay, and if we arrange this, simplify that, so that would be s squared plus a squared over s squared is equal to a over s squared. So what we are trying to find is the integral of this. So I can isolate this for us to find the Laplace transform of sine. So I can multiply this by the reciprocal of this. We have s squared over a squared plus s squared, or s squared plus a squared. That's still the same. So the integral or the Laplace transform of sine at is given by, okay, so this would cancel obviously. So we have a over s squared plus a squared. So therefore, the Laplace transform of sine at with a as any constant is equal to a over s squared plus a squared. Okay, so that means if we have Laplace transform, find the Laplace transform of sine 2t, okay, what we have here, sine 2t, our 2 is our a, so we have 2 over s squared plus 2 squared, because that's a squared, so we have 2 over s squared plus 4. So that's the Laplace transform. How about the Laplace transform of sine, let's say 5t, So we have again 5 because that's our a over s squared plus a squared, which is 5 squared. So we have 5 over s squared plus 25. So that is our Laplace transform. And I hope you guys learned something about the derivation of the Laplace transform of sine and cosine function. And if you find this video helpful, don't forget to share it with your friends and engineering friends. So thank you so much for listening. Thank you so much, and God bless.